Hello and welcome back. Welcome back. I'm John, an old YouTuber and PC gamer. I've just eaten my food, my evening food, and have charged the camcorder again. The Motorola is uploading. The Motorola, and they make two computer chips. The Motorola 6800 and the 68,000, so I'm going to read about that. But my English is not so good. I'm not going to read all this loud because I think that will not be so nice to listen to. So I do it with this computer voice. So this is, but that's 20 pages, and I have to watch the news in Danish television in like 50 minutes. The news 6:30 p.m. and of course I have to record a video about this war in Ukraine. I do that every evening, but I do that in Danish. This is the day 81. The day 81 after Russia have attacked Ukraine. So I start to make a video about that every evening. And I'll do that again today, number 100 I think, or more. I don't know, but that's many pages. And that's just the old computer chips, but I like to read it. I like to know something about this. But of course there's nothing to do with modern computer today, but this is how the microprocessor was in the old days in the 70s. I like to know something about that. And this is the Motorola 68,000. That's a little bit later, 1979. And this is 74 maybe. So I will try to keep me awake. But we can read 40 minutes. Read the whole document.
Motorola 6800. Motorola 6800 Motorola MC 6800 microprocessor.jpg. Motorola MC 6800 microprocessor. General information. Launched 1974. Common manufacturer S. Motorola. Performance max. CPU clock rate 1 MHz to tunes data width 8 address width 16 architecture and classification instruction set 6800 instructions 72 physical specifications transistors 4,100 package S 40-pin DIP history successor Motorola 68000 Mo 6502. The 6800 is an 8-bit microprocessor designed and first manufactured by Motorola in 1974. The MC6800 microprocessor was part of the M6800 microcomputer system that also included serial and parallel interface ICs, RAM-ROM and other support chips. A significant design feature was that the M6800 family of ICs required only a single 5-volt power supply at a time when most other microprocessors required 3 voltages. The M6800 microcomputer system was announced in March 1974 and was in full production by the end of that year. 1. 2. The 6800 has a 16-bit address bus that can directly access 64K of memory and an 8-bit bidirectional data bus. It has 72 instructions with 7 addressing modes for a total of 197 opcodes. The original MC6800 could have a clock frequency of up to 1 MHz. Later versions had a maximum clock frequency of 2 MHz. 3, 4. In addition to the ICs, Motorola also provided a complete assembly language development system. The customer could use the software on a remote timeshare computer or on an in-house MIA computer system. The Motorola Exorciser was a desktop computer built with the M6800 ICS that could be used for prototyping and debugging new designs. An expansive documentation package included data sheets on all ICS, 2 assembly language programming manuals, and a 700-page application manual that showed how to design a point-of-sale terminal, a computerized cash register, around the 6800.5. The 6800 was popular in computer peripherals, test equipment applications and point-of-sale terminals. It also found use in arcade games, 6, and pinball machines. 7. The MC6802, introduced in 1977, included 128 bytes of RAM and an internal clock oscillator on chip. The MC6801 and MC6805 included RAM, ROM and D/O on a single chip and were popular in automotive applications. The Motorola 6809 was an updated compatible design. Contents. History. Motorola's history in semiconductors. Development team. MC6800 microprocessor design. MOS ICS. M6800 family introduction. Design team breakup. Move to Austin. Use in personal computers. Example code. Peripherals. Second sources. Oral histories. See also. References. Further reading. External links. History. Motorola's history in semiconductors. Motorola began making semiconductors in the 1950s. Galvin Manufacturing Corporation was founded in 1928. The company name was changed to Motorola in 1947. They began commercial production of transistors at a new US $1.5 million facility in Phoenix in 1955. 8. Motorola's transistors and integrated circuits were used in-house for their communication, military, automotive and consumer products, and they were also sold to other companies. By 1973 the Semiconductor Products Division, SPD, had sales of $419 million and was the second largest semiconductor company after Texas Instruments. 9. In the early 1970s Motorola started a project that developed their first microprocessor, the MC6800. This was followed by single-chip microcontrollers such as the MC6801 and MC6805. Development team. Motorola did not chronicle the development of the 6800 microprocessor the way that Intel did for their microprocessors. In 2008 the Computer History Museum interviewed 4 members of the 6800 microprocessor design team. Their recollections can be confirmed and expanded by magazine and journal articles written at the time. The Motorola microprocessor project began in 1971 with a team composed of designer Tom Bennett, engineering director Jeff Lavelle, product marketer Link Young, and systems designers Mike Wiles, Gene Schreiber and Doug Powell. 10. They were all located in Mesa, Arizona, in Greater Phoenix. By the time the project was finished, Bennett had 17 chip designers and layout people working on 5 chips. Lavelle had 15 to 20 system engineers, and there was another applications engineering group of similar size. 11. Block diagram of AM6800 microcomputer system. Tom Bennett had a background in industrial controls and had worked for Victor Comptometer in the 1960s, designing the first electronic calculator to use MOS ICS, the Victor 3900. 12. In May 1969, Ted Horff showed Bennett early diagrams of the Intel 4004 to see if it would meet their calculator needs. Bennett joined Motorola in 1971 to design calculator ICs. He was soon assigned as the chief architect of the microprocessor project that produced the 6800.13. Others have taken credit for designing the 6800. In September 1975, Robert H. Cushman, EDN Magazine's microprocessor editor, interviewed Chuck Peddle about MOS Technology's new 6502 microprocessor. Cushman then asked Tom Bennett, master architect of the 6800, to comment about this new competitor. 14. After the 6800 project, Bennett worked on automotive applications and Motorola became a major supplier of microprocessors used in automobiles. Jeff Lavelle joined Motorola in 1966 and worked in the computer industry marketing organization. Lavelle had previously worked for Collins Radio on their C8500 computer that was built with small-scale ECLICs. In 1971, he led a group that examined the needs of their existing customers such as Hewlett-Packard, National Cash Register Control Data Corporation, CDC, and Digital Equipment Corporation, December. They would study the customer's products and try to identify functions that could be implemented in larger integrated circuits at a lower cost. The result of the survey was a family of 15 building blocks. Each could be implemented in an integrated circuit. 11. Some of these blocks were implemented in the initial M6800 release and more weaved over the next few years. To evaluate the 6800 architecture while the chip was being designed, Lavelle's team built an equivalent circuit using 451 small-scale TTLICs on 510 by 10 inch, 25 by 25 cm circuit boards. Later they reduced this to 114 ICs on one board by using ROMs and MSI, medium-scale integration, logic devices. 15. John Buchanan was a memory designer at Motorola when Bennett asked him to design a voltage doubler for the 6800. Typical N-channel MOS ICs required 3 power supplies, -5 volts, +5 volts and +12 volts. The M6800 family was to use only one, +5 volts. It was easy to eliminate the 5-volt supply by using an internal voltage inverter, but the enhancement mode logic also needed a supply of 10 to 12 volts. To address this, the design added an on-chip voltage doubler. Buchanan did the circuit design, analysis and layout for the 6800 microprocessor. He received patents on the voltage doubler and the 6800 chip layout. 16. 17. Rod Orgel assisted Buchanan with analyses and 6800 chip layout. Later Orgel would design MOS Technology 6501 microprocessor that was socket compatible with the 6800. Bill Latin joined Motorola in 1969 and his group provided the computer simulation tools for characterizing new MOS circuits in the 6800. Latin and Frank Jenkins had both attended UC Berkeley and studied computer circuit simulators under Donald Pedersen, the designer of the SPICE circuit simulator. 18. Motorola's simulator, Time, was an advanced version of the Time circuit simulator that Jenkins had developed at Berkeley. The group published a technical paper, MOS Device Modeling for Computer Implementation, in 1973 describing a 5V single-supply N-channel technology operating at 1 MHz. They called Simulator 50 MOSFET circuit on an IBM 370/165 mainframe computer. 19. In November 1975, Latin joined Intel to work on their next-generation microprocessor. 20. Bill Mensk joined Motorola in 1971 after graduating from the University of Arizona. He had worked several years as an electronics technician before earning his BSc degree. The first year at Motorola was a series of 3-month rotations through 4 different areas. Mensk did a flowchart for a modem that would become the 6860. He also worked the application group that was defining the M6800 system. After this training year, he was assigned to the 6820 Peripheral Interface Adapter, PIA, development team. Motorola 6800 DIP chip. Pinut Mensk was a major contributor to the design of this chip and received a patent on the IC layout, 21, and was named as a co-inventor of 7 other M6800 system patents. 22. Later Mensk would design the MOS Technology 6502 microprocessor. McBug was part of the extensive M6800 microcomputer support developed by Motorola's application engineering group. Mike Wiles was a design engineer in Jeff Lavell's group and had numerous customer visits with Tom Bennett during 6800. Products definition phase. He is listed as an inventor on 18 6800 patents but is best known for a computer program, McBug. 23. This was a monitor for a 6800 computer system that allowed the user to examine the contents of RAM and to save or load programs to tape. This 512-byte program occupied half of an MCM 6830 ROM. 24. This ROM was used in the Motorola MEK 6800 design evaluation kit and early hobby computer kits. 25. While stayed with Motorola, moved to Austin and helped design the MC 6801 microcontroller that was released in 1978. 26. Chuck Peddle joined the design team in 1973 after the 6800 processor design was done, but he contributed to overall system design and to several peripheral chips, particularly the 6820 PIA parallel interface. 27. Peddle is listed as an inventor on 16 Motorola patents. Most have 6 or more co-inventors. 28. Like the other engineers on the team, Peddle visited potential customers and solicited their feedback. Peddle and John Buchanan built one of the earliest 6800 demonstration boards. 29. In August 1974, Chuck Peddle left Motorola and joined a small semiconductor company in Pennsylvania, MOS Technology. There he led the team that designed the 6500 microprocessor family. MC 6800 microprocessor design. The Motorola 6800 and the Intel 8080 were designed at the same time and were similar in function. The 8080 was an extension and enhancement of the Intel 8008. Which in turn was an LS implementation of the TTL-based CPU design used in the DataPoint 2200. The 6800 architecture was a TTL-compatible LSI design modeled after the December PDP-11 processor. 30. The 6800 had an 8-bit bidirectional data bus, a 16-bit address bus that could address 64 kilobytes of memory, and came in a 40-pin DI package. The 6800 had 2 8-bit accumulators, a 16-bit index register, and a 16-bit stack pointer. Their direct addressing mode, often known as the 0 page in other processors, allowed fast access to the first 256 bytes of memory. I/O devices were addressed as memory, so there were no special I/O instructions. When the 6800 was reset, it loaded the program counter from the highest address and started execution at the memory location stored there. 31. The 6800 had a 3-state control that would disable the address bus to allow another device direct memory access. For instance, a floppy disk controller could load data into memory without requiring any support from the CPU. It was even possible to have two 6